The National Electrical Code provides exceptions to the 40% fill limit for conduits containing multiple cables. This exception applies when specific conditions are met, focusing primarily on cable arrangement and heat dissipation. The core principle behind this exception is to allow for more efficient use of conduit space while ensuring the safe operation and longevity of the cables. When installing multiple cables in a raceway, the standard 40% fill limit can be exceeded if the cables are not bundled. Bundling refers to the practice of tightly grouping cables together, often with cable ties or other binding methods. Bundling restricts the airflow around the cables, impeding their ability to dissipate heat effectively. When cables operate under load, they generate heat due to the resistance of the conductors. If this heat cannot escape, the cable temperature rises, potentially leading to premature insulation degradation, reduced current carrying capacity, and increased risk of electrical failure. The code emphasizes that cables should not be installed in a tightly packed formation. This requirement goes hand in hand with the prohibition of bundling. Even if cables are not physically tied together, if they are crammed into the conduit in a way that leaves little or no airspace between them, the same problems associated with bundling can arise. Proper installation involves arranging the cables in a manner that allows for some degree of air circulation around each cable. This might involve staggering the cables within the conduit or using separators to maintain spacing. A critical aspect of the exception is that the cables must not be restricted in their ability to dissipate heat. This condition encompasses both the cable arrangement and the surrounding environment. Even if the cables are not bundled or tightly packed, factors such as the conduit material, the ambient temperature, and the presence of other heat sources can affect heat dissipation. For instance, a conduit buried in direct sunlight or running through a hot environment will have a reduced capacity to dissipate heat compared to a conduit located in a cooler, shaded area. Similarly, a conduit made of a material with poor thermal conductivity, such as plastic, will not dissipate heat as effectively as a metal conduit. To ensure adequate heat dissipation, it is important to consider the overall installation environment and to select appropriate cable types and conduit materials. Factors that could impede heat dissipation include, firstly, bundling or tightly packing the cables, secondly, using a conduit material with poor thermal conductivity, thirdly, installing the conduit in a high ambient temperature environment, fourthly, burying the conduit in direct sunlight without adequate shading, fifthly, running the conduit near other heat sources, and sixthly, using cables with insufficient temperature ratings for the application. The implication of these requirements is that if the cables are arranged in a way that allows for adequate heat dissipation, the 40% fill limit can be exceeded. However, it is crucial to perform calculations to verify that the cable ampacity is not exceeded, taking into account the ambient temperature, the number of current carrying conductors in the conduit, and any other relevant directing factors. The National Electrical Code provides specific guidelines for directing cable ampacity based on these factors. The goal is to ensure that the cables operate within their safe temperature limits, even when the conduit fill exceeds 40%. When considering the conduit fill exception, it is important to carefully evaluate the specific installation conditions and to consult the relevant sections of the National Electrical Code. The code provides detailed requirements for cable ampacity, conduit fill, and directing factors. It is also advisable to consult with a qualified electrical engineer or inspector to ensure that the installation complies with all applicable codes and standards.